How sand turns into chips. This is a pile of sand. Pour the sand into a quartz dry pot and melt it at high temperature. Then get liquid silicon. Then put purple gold into the liquid silicon. Liquid silicon will slowly crystallize around the purple gold. When constantly pulling up, liquid silicon will continue to crystallize, thus drawing out a straight rule. Specified for extremely high purity, reach 11 nines. And then as needed, cut silicon wafers into 0.5 to 1.5 millimeters. Because the surface of the cut silicon wafer is not flat. Therefore, the wafer still needs to be polished. After completion, a qualified silicon wafer is formed. Then we can start chip manufacturing. Oxidation is required first. Cover the wafer surface with a layer of silicon dioxide. Then by deposition, layer another layer of silicon nitride on the silicon dioxide, finally using spin coating technology. Apply photoresist evenly to silicon nitride. The next thing to do is the photolithography process. This is also the most difficult step in chip manufacturing because a photolithography machine is needed. It is extremely difficult to manufacture photolithography machines, but the principle of photolithography is very simple. Use extreme ultraviolet light, irradiate onto the mask plate, with the circuit diagram engraved on it. The circuit diagram on the mask board is like this. Then the ultraviolet light passes through the optical lens. Focus on the bottom wafer. Thus, the circuit diagram on the mask board, engraved into the photoresist of the wafer. The UV light moves back and forth for engraving. A wafer can engrave hundreds of identical circuit diagrams. We zoom in on the wafer. Can be seen. Photoresist exposed to UV light is cured. That is the light blue square. The gray areas are not exposed to UV light. Then the photoresist in these places needs to be disposed of. How to deal with it? This requires development. Cover the wafer surface with developing solvent. When we zoom in on the wafer, can be seen gray areas not exposed to UV light. The photoresist has been removed by the developing solvent, exposing the green, faded silicon layer beneath the photoresist. Then the green dilute silicon layer is also etched away. Expose the bottom silicon wafer, and then clean it by. Remove the light blue photoresist layer. The next thing to do is to carve the stone. So how to do stone carving? Before answering this question, if you are interested in this popular science animation, you can download the Dye and Selected app in the lower left corner. Study. The collection Square Inside contains a large number of high-quality videos. If you are interested, you can download it closer to home. Before stone carving, the exposed silicon wafer needs to be. Then apply a layer of insulating silicon dioxide. Then put the crystal source into the stone carving machine. For stone carving, after passing through the stone carvings, both the silicon dioxide and silicon nitride layers were carved away by the stone. Leave the area we need. Then you need to find the correct location. Within these square grids, perform ion implantation to protect the yellow areas that do not require doping. At this time, it is necessary to apply another layer of photoresist, the same use of photolithography and development technology. Expose the areas we need. Areas that do not require doping are covered with. After the photoresist is completed, ion implantation can be performed. Ion implantation is mainly doping. For example, the common PN junction, lithium ions are implanted into the silicon surface, will form MEN-type semiconductor. Boron ions are implanted into the silicon surface. Then a P-type semiconductor is formed. Then put them together to form a PN junction. After ion implantation is completed, next, the photoresist can be removed. Observe the doped area. You can see that the conductivity of these areas is changed. After going through these steps, a simple transistor was carved out. This is not over yet. What's needed next? Perform electroplating to increase the electrical properties of the chip. Let's take an example of one of the transistors. Through electroplating process, precipitating copper ions onto the transistor, thereby coating a layer of metallic copper film on the surface of the transistor, then polish off the excess copper. Creates an extremely flat wafer surface. To here, we've made all the transistors. What to do now? Just connect these transistors to each other. This requires metallization. Through processes such as electron beam evaporation or construction deposition, forming metal lines on transistors. These metal lines crisscross though, connected in all directions, finally formed a extremely complex electronic traffic information network on a chip the size of a fingernail. There can be more than tens of billions of transistors. The manufactured wafers are then cut and encapsulate. When packaging, it is necessary to connect the contacts on the chip, connect to the lead corners of the package with wires. Finally, cover the protective shell. To here, a complete chip is manufactured. Have to be aware of this. The entire chip manufacturing process is extremely complex. Manufacturing processes operate at the nanometer level, and the entire manufacturing process exceeds hundreds of. This video greatly simplifies the process.